our understanding of the cosmos has never been fixed. It has evolved, fractured, and reformed with every generation of discovery. In the 1920s, Edwin Hubble estimated the universe to be roughly 2 billion years old. At the time, this was a revolutionary idea. It expanded humanity's perception of reality far beyond anything previously imagined. Today, using advanced observatories and precision measurements, scientists place the age of the universe at approximately 13.8 billion years. This shift is not just a correction in numbers. It is a reminder that even our most confident conclusions remain temporary, subject to revision as new evidence emerges. Even within our own galaxy, the Milky Way, mysteries persist. Observations of stars at its outer edges reveal motions that do not align with expectations. Instead of moving faster under gravitational influence, some stars appear to move more slowly than predicted. This discrepancy suggests that our understanding of dark matter distribution may be incomplete. The European Space Agency's Gaia mission has mapped nearly 2 billion stars with unprecedented accuracy. Its data has challenged long-standing assumptions about the mass of our galaxy. Some findings suggest that the Milky Way could be significantly lighter than previously estimated, perhaps even several times less massive. If true, this would force a re-evaluation of how dark matter shapes galactic structure. Understanding stellar motion and galactic mass is not a solved problem. It is an ongoing investigation. With every new dataset, astronomers refine their models, adjusting theories to match an increasingly complex picture of reality. Beyond our galaxy, humanity's gaze extends toward the earliest moments of existence. The James Webb Space Telescope has opened a new observational window into the distant universe. It detects galaxies that formed only a few hundred million years after the Big Bang, offering a glimpse into the first stages of cosmic structure. At the same time, the study of exoplanets has transformed our understanding of planetary systems. Thousands have been identified, many orbiting distant stars under conditions once thought impossible. Some exhibit characteristics that hint at potential habitability. One notable example is WASP 96b, where atmospheric analysis has revealed the presence of water vapor along with clouds and haze. While this world itself is far too hot to support life as we know it, the discovery demonstrates that complex atmospheric chemistry exists far beyond our solar system. It suggests that environments suitable for life may be more common than once believed. These discoveries raise profound questions. Could life exist elsewhere? If it does, what forms might it take? Could entire civilizations have emerged and vanished long before humanity ever looked outward? The search for answers pushes science toward deeper and more speculative territory. Theories such as the multiverse propose that our universe may be just one of many, possibly infinite in number. According to the many worlds interpretation of quantum mechanics, every possible outcome of a quantum event could unfold in separate realities. While these ideas remain unproven, they challenge the boundaries of what we consider observable and real. Another puzzling phenomenon is known as dark flow, an unexpected motion of galaxy clusters moving in a common direction at speeds that defy current models. This motion hints at influences beyond the observable universe, suggesting that unseen structures or forces may exist outside our cosmic horizon. Despite these uncertainties, one truth has become increasingly clear: the majority of the universe is invisible. Dark matter makes up roughly 27% of the cosmos, while dark energy accounts for nearly 68%, driving the accelerated expansion of space itself. Ordinary matter, everything we can see, stars, planets, and life, constitutes less than 5%. Understanding these unseen components may one day revolutionize physics, reshaping our understanding of gravity, space, and even time. Every observation expands knowledge, but it also reveals deeper mysteries. Each answer leads to new questions, forcing scientists to reconsider assumptions and explore beyond established frameworks. Among the most intriguing objects studied in recent years is HD 140283. Often referred to as the Methuselah star, located about 200 light-years away in the constellation Libra, it has become a focal point in discussions about cosmic age. Early estimates suggested that this star might be older than the universe itself, a paradox that challenged the foundations of cosmology. More refined measurements place its age at around 14.5 billion years, with a margin of uncertainty that overlaps with the accepted age of the universe. Even so, the implications are profound. If a star can appear to rival or exceed the universe's age, it suggests that our methods of measuring cosmic time may not be as precise as once believed. Determining the age of a star is a complex process. Astronomers analyze spectral composition, luminosity, and rotational dynamics. Over time, stars gradually lose rotational speed, similar to a spinning top slowing down. By comparing these changes across different stars, scientists estimate ages using techniques like stellar chronometry. But Methuselah reveals the limitations of these methods, showing that even our best tools can produce uncertainties in extreme cases. To better understand cosmic time, astronomers often use the concept of a cosmic calendar. In this model, the entire history of the universe is compressed into a single year. The Big Bang occurs at midnight on January 1st. Earth forms in the final days of December. All of human history occupies only the last few seconds before midnight. This perspective highlights how brief our existence is compared to the vast timeline of the cosmos. Age estimates of the universe rely heavily on observations of distant galaxies and the measurement of redshift, the stretching of light as space expands. These measurements consistently support an age of about 13.8 billion years. However, alternative theories continue to emerge. Some researchers have proposed that the universe could be significantly older, potentially extending beyond 20 billion years. These ideas often involve modifications to how light behaves over vast distances or how fundamental constants may change over time. Concepts such as tired light and varying interaction constants, once considered fringe ideas, are occasionally revisited in light of new anomalies. While not widely accepted, they reflect the willingness of science to question itself when confronted with unexplained data. The deeper we look into the universe, the less certain everything becomes. Observations from instruments like the James Webb Space Telescope continue to challenge expectations, revealing galaxies that appear more mature than they should be at such early stages of cosmic history. This raises a fundamental question. Is our model of cosmic evolution incomplete? Perhaps the early universe was not a slow, gradual process, but a rapid and intense period of formation. A time when stars ignited quickly, galaxies assembled at extraordinary speeds, and complexity emerged far earlier than expected. If so, then the universe is not only older in understanding, but also far more dynamic in its early behavior. And this realization changes something profound. The cosmos is no longer a predictable system governed by simple linear rules. It is a vast evolving structure filled with hidden forces, unexplained motions, and unanswered questions. From dark matter shaping galaxies to dark energy stretching space itself. From ancient stars challenging timelines to distant worlds hinting at life, every discovery expands the boundaries of what we know. Yet with each step forward, the horizon of mystery moves further away. The universe is not just something we observe. It is something we are still trying to understand piece by piece, photon by photon. And perhaps the most humbling truth of all is this. No matter how far we look, no matter how much we learn, the cosmos remains larger, older, and more complex than anything we can fully comprehend.